Topic 9, Electric Fields. Now we come to part 3, the last part. Uniform electric fields and formulas. Uniform field can be produced between two parallel metal plates, like these two, by connecting them to a power supply, like this. And E stands for electric field strength, or just electric field. D here stands for the separation, distance of separation between two plates. And V is the voltage put up by the power supply. And here it is. The electric field is given by E equal to V over D. The unit of A based on this formula is volt per meter. Just looking at the formula here, it's obvious. Now, based on this formula, we already looked at, the unit of E is Newton per Coulomb. So these two units are equivalent to each other. Here is an example. What we got here is, first of all, two metal plates like this, parallel to each other, and they are connected to a power supply of 48 volts. And in the middle between the two plates, there's a speck of dust. And it has collected that many electrons on itself. And you have to calculate all these values here, 4 values. This one here, that stands for electronic charge, means the charge of one electron. So E is a special case of Q. Here are the answers in detail. You can look through that yourself. But I want to point out question D. It says the speck being negatively charged will move towards the positive plate or to the right. In other words, will move against the direction of the field line. Potential difference in an electric field. Potential difference, abbreviated as PD, is sometimes loosely called voltage. Potential difference of voltage is the work done per unit of charge or per coulomb of positive charge when it is moved between 2 points such as A and B in the electric field. Formula is PD or V equal to W over Q, work per unit charge. So look at these field lines here, which indicate uniform field, and you've got 2 points, point A and point B, and here is a charge, positive charge, that's been pushed along in the direction of the field lines from A to B. With this example here, we can just refer to this diagram here. An electron is being moved from this plate to that plate against a potential difference of 30 volts, and you are asked to calculate the work done in moving the electron. And once the electron is at this plate here, it is then released so that it goes back to this plate. And then you are asked to calculate the velocity of the electron once it gets to this plate. And here are the answers. You can see that one is straightforward. And this one here, you have to equate gain in kinetic energy to the work done. And then bring in the formula, substitution, rearranging, eventually velocity is that much. Here are the 3 formulas you need to know in this topic.